There are several reasons why the neutral wire in older electrical systems tends to deteriorate more rapidly than the hot wire. The neutral wire carries the return current from all circuits, potentially leading to a higher overall current flow compared to individual hot wires. This increased current can generate heat, accelerating the degradation of the insulation over time. Furthermore, ground faults can cause surges of current through the neutral wire as the fault current seeks a path to ground. These surges can overwhelm the neutral conductor and damage its insulation. Loose connections are another common factor. Neutral wires are often connected to the neutral bus bar in the electrical panel or to metal boxes at fixtures. Over time, these connections can loosen due to vibration, expansion, and contraction, leading to arcing. Arcing generates heat and further breaks down the insulation. Oxidation also plays a role. The neutral wire is frequently exposed to moisture and air, particularly at connection points. This exposure promotes oxidation of the insulation, making it brittle and more susceptible to cracking and damage. Electrolysis can also contribute to the problem. If moisture is present and the neutral wire is in contact with a dissimilar metal, such as where copper wires are connected to aluminum components, an electrolytic reaction can occur, corroding the insulation. Mechanical stress can also impact the neutral wire. Neutral wires are often routed through tight spaces, behind walls, or within crowded electrical boxes, subjecting them to physical stress that can lead to tears, punctures, or compression of the insulation. To mitigate neutral wire deterioration, consider these preventive measures. Firstly, ensure all electrical connections are properly made and regularly tighten any loose connections. This minimizes arcing and overheating. Secondly, protect the neutral wires from excessive moisture and air exposure. Use appropriate enclosures and sealants where necessary, particularly in damp or corrosive environments. Thirdly, avoid overloading circuits. Overloaded circuits lead to excessive current flow, which generates heat and accelerates insulation breakdown. Fourthly, use high-quality wiring with durable insulation that is resistant to heat, moisture, and physical stress. Fifthly, regularly inspect your electrical system for any signs of deterioration, such as cracked or discolored insulation, loose connections, or evidence of overheating. Address any issues promptly to prevent further damage and potential hazards. The higher current draw on the neutral wire, the potential for ground faults, loose connections, oxidation, electrolysis, and mechanical stress all contribute to its faster rate of deterioration compared to the hot wire. Implementing preventive measures can extend the lifespan of your wiring and ensure a safer electrical system. The NEC, or National Electrical Code, provides guidelines for electrical installations and wiring practices. Following these guidelines is crucial for ensuring safety and preventing electrical problems, including premature wire deterioration. For example, NEC Section 310.15 addresses ampacity, which is the current carrying capacity of conductors. It's crucial to select the correct wire size based on the expected load to prevent overheating and insulation damage. NEC Section 110.14 addresses electrical connections, requiring that connections be made in a way that ensures a solid electrical connection without damaging the conductors. Proper termination techniques and the use of appropriate connectors are essential for preventing loose connections and arcing. Grounding and bonding are also crucial aspects of electrical safety addressed by the NEC in Article 250. A properly grounded system provides a low-impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing dangerous voltage buildup. Effective bonding ensures that all metal parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. When working with electrical systems, always energize the circuit before making any connections or repairs. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Regular electrical inspections are crucial for identifying potential problems before they become serious. A qualified electrician can inspect your wiring, connections, and other components of your electrical system to identify any signs of deterioration, such as cracked insulation, loose connections, or corrosion. They can also perform tests to check the integrity of your grounding system and the proper operation of circuit breakers and ground fault circuit interrupters, or GFCIs. When replacing old wiring, consider using modern wiring materials with improved insulation properties. For example, cross-linked polyethylene, or XLPE, insulation is more resistant to heat, moisture, and abrasion than older types of insulation such as thermoplastic high heat resistant nylon, or THHN. Also, consider using arc fault circuit interrupters, RFCIs, which are designed to detect arc faults, a common cause of electrical fires. RFCIs can provide an added layer of protection against electrical hazards. The NEC also specifies requirements for the installation of wiring in different types of locations, such as wet locations, damp locations, and dry locations. Wiring installed in wet locations must be specifically listed for use in wet locations and must be installed in a way that prevents moisture from entering the enclosure. Wiring installed in damp locations must be protected from moisture and corrosion. Wiring installed in dry locations can be installed in any manner that meets the requirements of the NEC. Furthermore, the NEC provides guidelines for the use of different types of wiring methods, such as conduit cable and open wiring. Each wiring method has its own advantages and disadvantages, and the appropriate wiring method for a particular application will depend on factors such as the type of building, the environment, and the budget. Understanding the reasons for neutral wire deterioration and implementing preventive measures can significantly improve the safety and reliability of electrical systems. Remember to consult the NEC and other applicable codes and standards for specific requirements and guidelines. If you are not comfortable working with electricity, always consult a qualified electrician. Electrical safety is paramount. Make sure to turn off the breaker before messing with any electrical components. Always use the proper safety gear for the job at hand. Make sure you know what you are doing, and if you don't, call a professional. The neutral wire serves a critical function in electrical distribution systems, providing the return path for current from electrical loads back to the source. In a typical single-phase 120/240 volt system, the neutral wire is bonded to ground at the service entrance, establishing a common reference point for voltage. This bonding helps to ensure safety by providing a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse. In three-phase systems, the neutral wire also serves to balance the loads across the three phases. If the loads are not evenly distributed, the neutral wire will carry current to compensate for the imbalance. This can result in higher current flow in the neutral wire compared to a balanced system. The size of the neutral wire is typically the same as the size of the hot wires in a circuit. However, in some cases, the neutral wire may be smaller than the hot wires if the load is primarily nonlinear. Nonlinear loads, such as electronic devices with switching power supplies, generate harmonic currents that can flow in the neutral wire. These harmonic currents can cause the neutral wire to overheat, even if the load current is within the ampacity of the wire. To address this issue, the NEC allows for the use of a reduced-size neutral wire in some cases, but only if certain conditions are met. The NEC requires that the neutral wire be sized to carry the maximum unbalanced load, which is the difference between the current in the most heavily loaded phase and the current on the least heavily loaded phase. If the load is primarily nonlinear, the neutral wire may need to be sized larger than the hot wires to accommodate the harmonic currents. When working with electrical systems, it's important to understand the function of the neutral wire and the potential hazards associated with it. Always energize the circuit before making any connections or repairs. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. It is essential to understand the role of the neutral wire in electrical circuits and the factors that contribute to its deterioration. By following proper installation practices, performing regular inspections, and addressing any issues promptly, one can ensure the safety and reliability of electrical systems. The National Electrical Code, or NEC, serves as a comprehensive guide for electrical installations, providing detailed requirements for wiring methods, grounding, overcurrent protection, and other aspects of electrical safety. Adherence to the NEC is crucial for preventing electrical hazards and ensuring the safe operation of electrical systems. Electrical systems should be inspected on a regular basis by a qualified electrician. These inspections can help identify potential problems before they become serious, such as loose connections, damaged wiring, or overloaded circuits. Regular inspections can also help ensure that the electrical system is in compliance with the NEC and other applicable codes and standards. When working with electrical systems, safety should always be the top priority. To energize the circuit before making any connections or repairs. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. With proper care and maintenance, electrical systems can provide safe and reliable service for many years. It's essential to stay informed about electrical safety and to take precautions to prevent electrical hazards. By understanding the principles of electrical safety and following proper procedures, individuals can protect themselves and others from the dangers of electricity. Remember, electrical safety is everyone's responsibility.